In Chapter 2, we've talked about derivatives a lot. We've gone through a bunch of rules for finding derivatives of certain functions, including sine and cosine. What we're going to do today in section 2.6 is find the derivative of tangent, cotangent, secant, and cosecant. To help us with that, we're just going to do a quick reminder on a couple of trig identities. So one of them was if you have the sine squared of x plus, and that was missing an x there, plus the cosine squared of x, it always equals 1. So that was a trig identity you guys learned last year. We reviewed that when we did that chapter 0. Another one is a tangent of x. You can write tangent of x in terms of sine and cosine. It looks like this. Sine of x over cosine of x. Secant of x can also be written in terms of sine and cosine. It can be written as being 1 over the cosine of x. So keep those three trig identities in mind. They're going to help us as we go through and find the derivative. We're just going to do the derivative of the tangent. I'll show you where it comes from. We'll go through it step by step, and also of the secant. So we'll start with tangent. So I'm going to start by taking the tangent. I don't know how to find the derivative, but I can rewrite it as being the sine of x over the cosine of x. And the reason why I did that is because even though I don't know how to take the derivative of the tangent, I do know how to take the derivative of sine and cosine. Now, in order to do that, this is now a quotient, right? We got sine of x divided by the cosine of x, so I'm going to have to use the quotient rule. So let's do that. So that derivative equals, I take the bottom, cosine of x, times the derivative of the top. The derivative of the sine of x is the cosine of x also. Minus, I take the top, sine of x, times the derivative of the bottom. Derivative of the cosine of x is negative sine of x, all over cosine squared of x. Okay, so that's all just using the quotient rule. I'm going to do some simplifying here. Cosine of x times the cosine of x is the cosine squared of x. And minus sine of x times the negative sine of x, those two, the minus and the negative, when I multiply those, end up being a plus sine squared of x. And that's all over the cosine squared of x. Okay, I take the numerator, cosine squared plus the sine squared. That's one of my identities up here, right? That's the same as the sine squared plus the cosine squared. It comes out to be 1. So I end up with 1 over cosine squared of x. Well, 1 over the cosine squared of x, 1 over the cosine is right up there, right, is the secant. So 1 over the cosine squared is the secant squared of x. So there's our derivative. The derivative of the tangent of x is the secant squared of x. And again, you can show that just like I did there by switching tangent to be sine and cosine and by using the quotient rule. Okay, let's do the same thing with the secant of x. We're going to find the derivative. So I'm going to rewrite it as being the derivative of the secant is the same as the derivative of 1 over the cosine. Okay, and to find that, again, I'm going to use the quotient rule. So I take the bottom, cosine of x, times the derivative of the top. Well, the derivative of 1 is 0, minus the top, 1, times the derivative of the bottom, which would be negative sine of x, all over the denominator squared, so the bottom squared, so cosine squared of x. Well, cosine of x times 0 is just 0. That goes away. A negative 1 times negative sine of x would be 1 sine of x. So sine of x over cosine squared of x. I'll just separate this so we keep it all separate. Okay, so that's my answer. Now I'm going to take it and just manipulate it a little bit so I can write it in a different form. I'm going to write it as being the sine of x over the cosine of x times by 1 over the cosine of x. Are we good? The cosine of x times the cosine of x is the cosine squared of x. Well, the reason why I did that is because I know what the sine of x over the cosine of x is. That's the tangent of x. And I know what 1 over the cosine of x is. That's the secant of x. Okay, so there's a derivative of the secant. It's the tangent of x, secant of x, or secant of x, tangent of x, however you want to write that. So there's a couple. Now, we could do the same thing with the cotangent and the cosecant. And if you're interested in that, I would say go for it. You do a really similar process, right? Cotangent, instead of being sine over cosine, is the cosine over the sine. But you do the same thing. You do the quotient rule. The cosecant, right, instead of being 1 over the cosine, is 1 over the sine. So you go through those same steps, and you could get those. We're just going to skip ahead and look at the summary of the rules here then, right? So these are all our derivative rules. These are the ones we've done already. We got Sine of x is the derivative of the sine is a cosine. Derivative of the tangent, we just did that, is the secant squared. Derivative of the secant is the secant tangent. Derivative of the cosine is negative sine. Now these other two we didn't do, but again, you can try them if you want. But if you take the derivative of the cotangent, it comes out to be negative cosecant squared. And the derivative of the cosecant is negative cosecant cotangent. So those are all of our derivative rules for our 6 trig functions. I want you to notice something. Probably the biggest mistake, we're just going to memorize these, right? So from now on, you're not going to, like back here, right? We're not going to go through all these steps when I ask you to find the tangent of x. You're just going to have memorized that the tangent of x is the secant squared of x. As you go through and memorize these, one of the biggest mistakes is we get incorrect signs. So one quick little easy thing that you can see that will help you with the signs is this. If you look at this, as long as it starts with a c, when I take the derivative, cosine, cotangent, or cosecant, you always end up with a negative. The other 3, right, sine, tangent, and secant are all positive. So that's a little trick that may help you remember how the signs work on that. Okay, let's just use these now. We're going to apply them and just along with all our other derivative rules just to find derivatives. So let's start with number 1. It says find the derivative of 4 cotangent of x. Well, 4 is just a scalar multiple, so the 4 doesn't change. It just stays out in front. So 4 times, and I just take the derivative of the cotangent of x. So look at your rule there. The derivative of the cotangent is the negative cosecant squared of x. If you multiply those together, just simplify, it'd be negative 4 cosecant squared of x. If you look at number 2, we're going to need a little bit more room for number 2. I'm just going to slide it over a little bit. I can here. Actually, I'll just come down underneath here. So if I want to find y primed, I want to find the derivative. This one I'm going to have to use the product rule because I have the e to the x times tangent of x are multiplied together. So to do the product rule, we're going to come down here. I'm going to take the first e to the x times the derivative of the second. So the derivative of the tangent of x is the secant squared of x plus the second tangent of x times the derivative of the first, which is e to the x. There's not a whole lot we can do there to simplify, so we're done. There's our derivative. Again, I had to use the product rule, and within the product rule, I had to use the rule for tangent and for the derivative of tangent and derivative of e to the x. Number 3, so if we're going to do this one now we have to use the quotient rule, right? I've got the cosecant of t over t squared. So to find f prime of t, put it over here. So to find f prime of t, I'm going to take the bottom, t squared, times the derivative of the cosecant of t. So look at your rules there. That is a negative cosecant of t cotangent of t minus the top cosecant of t times by the derivative of the bottom, which is 2t. Okay, all over the bottom squared. So t squared squared is t to the 4th power. That's my answer. I'm going to try to do a little bit of simplifying here. So up on top, that would be a negative t squared cosecant of t cotangent of t minus 2t cosecant of t all over t to the 4th. And there's not a whole lot we can do there, but if you do look, there is a factor of t on top and a factor of t on the bottom. So if I factor out that t, take it out, so I'm going to go t times negative t cosecant of t minus 2. Oh, I left off my cotangent, sorry. So minus t cosecant of t cotangent of t minus t cosecant of t all over t to the 4th. Ooh, hold on, that doesn't want to work. And then let me slide it down just a little bit more. All over t to the 4th. And what I can do now is cancel out that t with one of those. So I guess you could simplify it a little bit like that, but there's not much else we can do besides there. So there's my answer. A negative t cosecant of t cotangent of t minus t cosecant of t all over t to the 3rd. The hard part on there, right, is just there was the quotient rule, right? It's getting long. As far as the actual derivative of the cosecant, it's pretty simple. It's just a matter of knowing the rule. Okay, number 4. I'm going to erase this over here so I can have a little more room to work. But number 4, I have g of theta equals secant of theta times the ln of theta. Again, those are multiplied together. So to take the derivative, I'm going to have to use the product rule. So g prime of theta is going to be equal to, I take the first secant of theta times the derivative of the ln of theta plus the second ln of theta times the derivative of the first. Well, the derivative of the secant, look at your rules there, is secant of theta, oh, mine just went blank there, tangent of theta. Sorry about that. Okay. If we can simplify something, we ought to. I don't think there's really much you can do to simplify. I guess if you wanted to, you could put the times by 1 over theta like that. But there's not a whole lot else we can do here. Okay, there's my answer right there. Hey, the last couple of examples, right, they say without a calculator, find the slope of the graph of y equals -3 tangent of x. Hey, as soon as I hear slope of the graph, okay, right, we just got to program our minds. In calculus, that means derivative. So I've got to take the derivative, and I want to find it at pi fourths. So I'll take the derivative and plug in pi fourths and plug in -pi thirds. So let's find the derivative first. That one's pretty easy. This one's nice. That's -3 times the tangent of x. -3 is a scalar multiple. So I just take -3 times, and the derivative of the tangent of x is the secant squared of x. Sorry, I'm finding the derivative. Okay, there's my derivative. Now I just need to plug in pi fourths and -pi thirds to find my answer. So over here, I'm going to take y primed of pi fourths. All right, so if I plug in pi fourths, I get -3 secant of pi fourths. And remember, when you take the secant squared, it really means this. Just take the secant of pi fourths and then square the answer. So we've got to figure out the secant of pi fourths is. I'm going to draw a reference triangle to help me with that. Pi fourths is right there. It's a 45-degree angle. There's my triangle. I know my sides are 1, 1, square root of 2. It's a +1 because you're going to the right, a +1 because you're going up. I'm going to do cosine. The cosine of pi fourths is adjacent, which is 1 over hypotenuse, which is just the square root of 2. So it's 1 over the square root of 2. Secant then has to be the reciprocal. So it's going to end up being -3. Instead of being 1 over the square root of 2, it's going to be the square root of 2 over 1. So just the square root of 2. We can keep going there. Square root of 2 squared is 2 times 3 is -6. There's my slope. Okay, same thing. Look at B. We're doing the exact same thing, but this time in my derivative, I'm plugging in -pi thirds. So if we plug in -pi thirds, that's going to equal -3 tangent of -pi thirds. Okay. Oh, hey, I just made a mistake. Don't do that. I'm not plugging it into this, right? I'm not plugging it into there. I'm plugging it into the derivative. I apologize. So that'd be -3 secant of -pi thirds squared. Okay. So I got to figure out the secant of -pi thirds is. So again, draw your reference triangle. Remember, a negative angle means you're going backwards pi thirds. That's a 60-degree angle. So this is 60, 90, this is 30. Do your sides. So the short side's a half. Yeah, +1/2. Oops. That's not correct. Sorry, I'm struggling here. Let me fix. So the sides we did with the 30, 60, 90. We said the hypotenuse was 2. The short side was half of 2, which is 1. And then the long leg was square root of 3. Be careful of signs. 1 is positive because I'm going to the right. Square root of 3 is negative because I'm going down. And then the hypotenuse is 2. So secant's the reciprocal of the cosine. Cosine is adjacent, which is 1, over the hypotenuse, which is 2. So the cosine's a half. So the secant would be 2. So this equals a -3 times 2 squared. 2 squared is 4 times -3. -12 would come out to be my slope. The hardest part on there, right, is evaluating the trig functions. That's the part you really got to be careful with. The derivative really isn't that bad. Okay, so we're adding up. We got lots of derivative rules right now, right? We have the power rule. We have the derivative of e to the x, ln of x, sine, cosine. Now we have cosecant, secant, cotangent, and tangent. We have the product rule, the quotient rule. It's going to become a little overwhelming. So part of the review process, right, is going to be going back and we're going to make some flashcards and just memorize. So we're just going to start memorizing all these. And, practice, practice, practice until you have them done. Okay, appreciate it, guys.